Hello, students. This is the subject of fundamentals of information technology. The textbook that you have to refer is ITL Education Solutions Limited Introduction to Information Technology. So, this is actually one of the basic subjects you need to know when you are studying in BCA, and it is actually the base for all the rest of the subjects that you will study. So this is something even kind of easy, theoretical, and most of the things you might know if you have studied computer science in your PUC. Most of the things you will know beforehand. So we'll be just brushing up whatever we know from your previous class. So the word computer came from the Latin word which means compute. So it refers actually to a program or a programmable electronic device that can store, retrieve, and process data. Computer is an electronic device operating under control of instructions like software, and it's stored in its own memory, and it can input the data, output the data, process it, and manipulate the data as necessary. So when we speak of computers, so many things come into picture, like for example information, data, and the difference between the similarities between them. So first thing is information, which is it comes from the Latin word informatio, which means an answer to a question from which a knowledge and data can be retrieved. So if that is so, then what is data? Data is nothing but it's like a raw material for a processing. See, you input the data, you get the things done, and you get the output as information, which is that is useful, from which you can derive something, you can do something. So that is called as a data. So information, how is it similar to data? It is nothing but the data that has been processed in such a way as to be meaningful to the person who receives it. Why would we need this information or the information technology as such? We know this is an era of information. You get a lot of information around you. But until and unless you are able to process that information, that data is of no use. For example, let us say the conductor in a private bus, he has that machine, right? The ticket machine, where he enters from where you have to where you have climbed the bus, and he will where he will ask for your destination, and he will give you the ticket or the amount that is required to pay. He'll give a bill of it. See, there are so much information in it, like at what time you have got into the bus, at what time you will actually get on, like if it's possible to get that information, and how much you have paid, all those things. But we are not actually using that information, and for just for the checking of ticket purpose we can use that, but other than that, once you get down from the bus, we usually never use that, other than to get the amount of sales that has been done through it. So only if you use that kind of data, you can say that the data has been converted into information. For example, from that, if we can get to know that how many people daily travel through a bus in a exact time from the exact stop to the destination, exactly they climb from one spot and get down at the destination. So how many people are there? So what could be the bus capacity usually, or how many seats will be taken? So all this information, if the owner of the bus needs or the conductor of the bus needs, to some extent they can actually get that information. So for all these purposes we have computer, right? So what is a computer? It is actually now a general purpose electronic device that can be programmed to carry out set of arithmetic or logical operations automatically, of course, without the intervening of the user. So Why this without the intervening of the user? In the sense, to some extent he has to intervene, like he has to put the input, he has to he has to ask the computer what to do, he has to give commands to the computer, but other than that, rest of the things, the output, the result, everything will be given by the computer itself. So what are the characteristics of computer? It's nothing but speed, accuracy, reliability, memory and storage. You all can understand what are these, right? What is speed? Speed is nothing but the computer can calculate something or type something or do in a fraction of a second. It doesn't need time to do those things. Accuracy, no matter how long you are doing it, for how short time you are doing the work that you assign for the computer, it is done with 100% accuracy. There are no mistakes at all. Then reliability, how reliable the answers of the computer or the result of the computer you are doing we get. It's very reliable, right? You cannot actually say whether, we don't know whether it's right or wrong, the computer has given it. We don't say that. We say that the answer or the result is given by the computer, it has to be 100% right? That is a reliability. Next is memory. Of course, you know that computer has a memory. Whatever we do, we can save it in the computer for future reference or use. So it has a memory. And data storage, after doing all your calculations, results, it will be stored for your future use, right? So that is a storage. So what are the main components of this computer? It's nothing but input devices, processor, output devices, and while the processor is doing, you can go back and forth to your storage. Then the main components, it's input, CPU, arithmetic logic unit, memory unit, control unit, and the output is given. We'll see these things in detail in the coming slides. The major components of a computer are memory. You know, memory is very important for a computer. Until and unless you can save anything on the computer, whatever you do is of no use. So then, to get computer into use, we need to put something to the computer like input. So input devices are required. Usually it's a keyboard or mouse. Output devices, you already know what are output devices, like monitor, printer, etc. Central processing unit, the CPU, you know, it has three things. They are control unit, arithmetic and logic unit, and memory unit. Control unit controls the computer, like giving commands or getting the results. The commands for getting the results are kept or the control by the control unit. Arithmetic and logic units is for actually the mathematical calculations, and the programming results that you need to get from the computer are done from the arithmetic and logic units. And the memory unit, as you know, it's used to store. Next is the evolution of computers. You know, there are actually 5 generations of computers. The computers that were once started, it starts from 1940 with the vacuum tube circuitry that goes with the present day and beyond with artificial intelligence. See, these vacuum tubes are nothing but, you can just think of them as, you know, the old equipments, or like, you know, you can say something that used like kind of, you know, the old equipments, you can say. Technically to say, it is a tube that is actually required for the computation, that was actually required, and millions of them had to be, you know, change their place so that you get the actual result to compute here. And magnetic drums were used for memory, that is for storage. Later on, like, it were converted, like the newer version came, like magnetic tapes, magnetic discs. So these were the magnetic drums were the older ones, and it was very large in size, and it always took almost, like, you know, the entire room, and very expensive to operate, and it needed a large amount of electricity, and a lot of heat was generated. And to overcome these things, what was done, the second generation came into picture. So they replaced vacuum tubes with the transistors. And what else the first generation used? It relied on machine language, that is lowest programming language that only understands 0 and 1. And input was based on punch cards, so there were no input devices as such, or the highly developed input devices, but they were just punch cards and paper tapes. And output was displayed on printouts, as do we get now, it was given on a printout. And UNIVAC and ENIAC computers are the examples for first generation this generation computers. They are named so as a UNIVAC and ENIAC. So when the transistors came, they replaced the vacuum tubes. It is actually, you can say, why this transistor came. It's because science was evolving. Earlier when they used vacuum tubes, it consumed a lot of space, energy, like in terms of electricity. It required more even human powers also to operate it. So when they replaced transistors are very small device compared to vacuum tubes. So in the second generation, transistors were used, and it worked faster, it was smaller, it was cheaper, and more energy efficient, and more reliable than the first generation predecessors. And next, so the heat that was generated in first generation, it was very low compared to the in the second generation compared to the first generation. So again they used punch card for inputs and printouts for output. And they used from binary languages or the machine level language to assembly language. I told you machine level language means zeros and ones, so that is also called as binary machine language. Next, it was converted to assembly languages, which allowed programmers to specify instructions in words. You will know what are these in depth in the coming chapters and even in the coming semesters. High level programming languages were being developed at this time. They were developed but were not that useful, and versions of COBOL and Fortran came during this time. And instead of magnetic drum, magnetic core technology was used. So some of the examples are IBM 7000, NCR 304, IBM 650, IBM 1401. These are the examples. Next came the third generation, and they were transistors replaced by integrated circuits. These are silicon chips, you can say semiconductor, or a small device that is that can be replaced by that replaces transistors. So instead of punch cards and printouts, keyboards and monitors were used. So this is where actual the computer comes into picture actually, and it has operating systems, and it had many applications, and it were smaller and cheaper compared to your second generation. And so it became more many people started using it, and it used high level language, so it was easy to program. High level language is nothing but a language that is we give, or the instructions we give in a simple English sentences. Is a combination of maths or kind of instructions and English language. So those are high level programming language. And magnetic core and solid states were the main storage devices. PDP-8, PDP-11, ICL 2900, IBM 360 and IBM 370 are some of the examples. Next comes the fourth generation, and this used microprocessor. Even now the computers uses this, but there are very much improved version of this, but at that time it was it had come to market, the microprocessor. And the computers that use microprocessor were called the fourth generation, and it had integrated circuits that were built into a single silicon chip. Like many integrated circuits were put into single chip, and its size was very small, it can fit in your palm. And even the computers became you could integrate through them through networks, and they were eventually developed into internet. And again, high level languages were used to develop, like COBOL, Fortran, BASIC, Pascal and C. And development of GUI, that is graphical user interface, GUIs, and mouse and handheld devices came in this generation. So IBM 4341, DEC 10, Star 1000, PUP 11 and Apple II were the systems in this generation. Next is a fifth generation. So it is based on artificial intelligence. That is what we it is now it is becoming popular, and it is a future vision. Artificial intelligence is the future of